Hello and welcome to IoT Builders, a live stream where we discuss a range of topics on Internet of Things, starting from embedded devices to cloud services, all from the IoT Builder perspective. Today is June 14th, and this is episode 32 of our weekly live stream. And my name is Nenad. I'm a senior developer advocate for IoT at AWS. And in this episode, we'll talk about Amazon Sidewalk. And joining me today to discuss this topic would be Ben Cook. He's a senior partner solution architect for IoT at AWS here. Hi, Ben. How's it going?
Hey, Nanad. Hey, thanks for having me on. I'm really excited to talk to you a bit about Amazon Sidewalk and AWS IoT Core.
Yeah, me too. I'm generally excited about this topic. It enables us to connect our devices, so it's like really important for the IoT infrastructure overall. But before we jump into this interesting topic, maybe you can start introducing yourself just to see,
I'd be happy to. So I am a senior partner solutions architect. I'm part of our IoT service acceleration team here at AWS. I've been with AWS for a couple of years now. Prior to that, I was with ARM for a number of years, leading field applications or solution architecture for Pelion device management. And early on in my career, I spent a lot of time doing embedded hardware design for set-top boxes, network interfaces, things like that. But then I really found my passion, I think, as I moved over to the semiconductor industry with field applications and really helping, being able to help customers build some pretty incredible things. And so happy to be here.
Nice, that's pretty cool. But talking about connectivity and the embedded devices and so forth, I'm really curious, since you've been working on this Amazon Sidewalk, like maybe you can explain it in like simple terms, like how does it work, and then how does it actually benefit the average consumer at the end? So let's start with an easy question.
Yeah, absolutely. So Amazon Sidewalk is an LPWAN network of pretty massive scale that leverages the a broad population of Echo and Ring devices in the field, found at customer homes, that enables a few different PHYs, a few different radio types to interact with the network and the cloud. These are BLE, FSK, and CSS, or chirp spread spectrum, also known as LoRa. And it really provides, I think, to the end consumer some really nice benefits. And I feel like any sufficiently good technology kind of fades into the background of our lives. And Sidewalk, I think, brings LPWAN technologies closer to that. Mm-hmm. And what I mean by that is, I think most are probably familiar with LoRaWAN and its capability of very long range, very low power. When you bring in these other technologies with Sidewalk, with FSK and with BLE, you start the end consumer kind of doesn't have to worry much about commissioning a Wi-Fi device with local credentials, or managing a SIM card, for example, for cellular connectivity. And so what Sidewalk does is it brings in these three different PHYs, these three different low power wireless technologies, non-IP technologies, and enables the devices to send messages through the cloud without having to manage the network or the gateways out at the edge.
Yeah, this is pretty cool. I really like how you said this. Like Internet of Things is about the internet protocol, and you have those devices that are connected via Bluetooth and other types of protocols that are not on top of the internet protocol, and having something that kind of abstracts that, so that at the end of the day, those devices can also connect and you can interact with them through the internet is like, yeah, pretty cool. As you said, it's allowing this to kind of blend in for the end consumer. So this is pretty cool. But I remember, what you said, like Bluetooth and there is like a LoRaWAN as well? Like, how does that differ?
Yeah, sure. I can talk a bit about that. So, I mean, yeah, I mentioned one of the PHYs that one of the radio types that is used is CSS or LoRa. This is not LoRaWAN. So, LoRaWAN as a network or as a network technology.
Hmm.
LoRa is really the physical link, using chirp spread spectrum, and it's similar in some ways, very different in others. In that, again, it's designed for very low data rate, very low power devices, and we can get the significant range of what CSS provides. And it works. I'll say it's similar in a way, in the way that uplink, downlink windows work, or
Hmm.
downlink windows work with LoRaWAN in a way. The devices kind of beaconing off their uplink messages and providing a downlink window quickly after that in order to interact, to provide downstream communication with it. But that's I'd say where the comparison kind of will stop, and there's quite a few differences around the security and the I'll say even the device onboarding
Hmm.
using that PHY. And so again, it can be seen as similar, but again, one of the big differences here is that the sidewalk network is managed and is built from these millions of echo and ring devices that
Hmm.
these radios, that just again kind of provides this background network, if you will, that devices are able to roam between. I mean, when you build a sidewalk device, you again don't have to worry about the gateway, and as the device could potentially move around in an asset tracker perspective, uh,
Hmm.
the closest gateway in earshot, will pick it
Yes.
up and forward the messages on.
Yeah, but okay, so this is pretty cool. Thanks for kind of putting that into perspective. I'm now also wondering, like, how does this technology, the Amazon Sidewalk, interacts with other existing networking technology like Wi-Fi and cellular network? Like, how does that compare, and how does it work together?
Yeah, so they're different. I guess it's certainly different performance and kind of power
Hmm.
profiles with other. If you look at IP connected technologies like that, wireless technologies like Wi-Fi or cellular, um, where Sidewalk is interesting for a number of different use cases. But honestly, I think in combination with some of these other IP technologies, it has a potential to augment devices to be able to provide a kind of low level, always connected background link that could complement things like Wi-Fi or cellular.
Hmm.
Think of it as maybe a potential side channel to commission Wi-Fi devices, for
Hmm.
example. So they, again, could be headless and provide a common kind of side channel transport, if you will, for device configuration. And you could see a number of use cases where if you've got a device that if it needs to send a lot of data, it could wake up and use Wi-Fi, but maybe
Hmm.
to maintain a really extreme battery life, outside of a critical event or something, it could use Sidewalk in order to surface that data.
I see. I see. Yeah, I mean, this is pretty cool. So basically, it kind of preserves the battery while using, let's say, BLE, ZigBee, or whatever other kind of, let's say, low power consumption protocol. That's not IP. That then connects to the infrastructure. This echoes, devices, and whatever that are then connected either via Wi-Fi or like just plain Ethernet. Okay,
Yeah, yeah.
uh, that's pretty cool. Okay, cool. Um, I'm also wondering, like, when it comes to Sidewalk and the application layer, and then what do you think are interesting applications that can be built on top, and if you've seen any, maybe you can talk about that.
Yeah, yeah, I can certainly do that. And it is again, each radio type really provides enables kind of various application use cases. And if you think about the network and really where it's deployed, again, it covers 90% of the US population currently. And knowing that the gateways or bridges are consumer devices, we look a lot at the kind of home and life use cases that are centered around population centers. And so if you think about home use cases of maybe durable goods like appliances that maybe previously they had to be Wi-Fi connected, maybe the users aren't doing that. Appliances are one that could really greatly benefit from this technology in order to provide troubleshooting feedback to the teams without the consumer having to worry about connecting them. They can be kind of connected by default in a way.
I see.
The other ones where it's really interesting too around the home are, I mean, if you think of lawn and garden kind of applications where Wi-Fi is good maybe within under the roof of the home, but then as you get further out into the yard, the range, the coverage just isn't quite there. And so bringing in, an FSK or a LoRa radio type really starts to extend that sphere of connectivity around a home and provides for, I think, some interesting use cases around, irrigation and water management for the home. So again, kind of your typical IoT, and environmental sensors.
Nice.
But then, one other that I'll mention that's very, I think, a popular, exciting one is kind of the location tracker use case.
Yes.
As I mentioned before, that these devices are able to interact really with any gateway within range. And so, and I've actually got a demo of a coverage test kit of kind of a tracker that I'll show you as well that
Nice.
that leverages Sidewalk. And you'll see as these devices are able to, they're mobile and are moving around in the world, they're able to pick up and these the gateways and send data, almost anywhere. And so it's again it is not high bandwidth. And if you look at these three radio technologies, BLE, FSK, and CSS, you kind of have short, medium, and long range. And so conservatively speaking, 10 meters, 100 meters, 1,000 meters, and with the bandwidth kind of the inverse of that. And so there are, because this is a shared kind of shared public network, there are limitations around the MTU, the data size provided, but think in the order of hundreds of bytes sent. So if you're I'd say frugal with your payloads and you can really make every bit count, there's a lot of benefit that can be had from it, but you're not going to be streaming video over it. So.
No, but I mean, this is pretty cool. But on the other side is kind of like, this allows you to, as you said, have something that can move, and then you utilize that network throughout the, I guess, United States right now as kind of just and from the, let's say, from the OEM perspective, or from the perspective who are kind of building those devices, that is kind of landing in their account more or less this data, so there is no bulky provisioning process as well, right?
Exactly.
So that is kind of on the other side benefit, plus the energy consumption, which is as you said, low to this kind of different technologies. Okay, that's cool. But I mean, thinking about all of this, like I'm thinking, what industries like this Amazon Sidewalk will be kind of impacting. I probably know some stories about healthcare that this could be really useful. Do you have any other stories you can share?
Healthcare is a perfect example of this, and I'm going to use BLE as a kind of comparison here. Is that I'll tell you, I've worked with a lot of connected device customers over the years, and the use case that was always actually fairly challenging is the BLE use case.
Yes.
You can build a BLE device, and maybe in the healthcare industry, we have a customer that produces a specialized sensor, patient monitor, if you will. And if you look at their journey to try to deliver this product to market, and they may specialize in the signal processing and potentially some machine learning of that patient data, in order to provide insights into the patient's health. But if you look at this from a connectivity standpoint, there may be sensor specialists, and so they could build a low power BLE device, a wearable that a patient could wear at a hospital. Well, they need to get that data to the cloud. And
Mm.
so, taking kind of a traditional protocol translation approach with BLE, with GAT and GAP, they now may have to build a BLE gateway that is
Yes.
capable of doing the protocol translation that would be deployed in a hospital. And say now that patient wants, the patient gets discharged and is going to be monitored from home with that same sensor. Well, now they could leverage smartphones, which is a very common use case for getting BLE data to the cloud, is an app on a phone. But now they've got, two more projects, and Android and iOS, mobile apps to develop. And then, for elderly patients, they might not have a
Yeah.
smartphone, and they need to come up with a low cost, headless gateway here. So now this, one project has kind of spiraled into a number of different gateway projects that they now have to build and maintain. And so if you contrast that with Sidewalk, where they could build this sensor that is connectable and to this network, utilize the same kind of
Mhm.
power profile and benefits of BLE and low cost. With Sidewalk now, they can implement that without having to worry about the gateway or the management and maintenance of that protocol translation layer.
Pretty cool. No, this is really interesting. I remember, back in the days, as you rightly said, we had a similar situation where, we had to have, apart from like development of the hardware, like embedded system engineers, the hardware designers, all that, we also had to have like mobile developers and all of this. But then with this kind of thing, that it fades away, and then same technology can be used. That's really powerful. Any other industries you think? I mean, I think you mentioned logistics, right?
Yeah, logistics is another one. Again, there's a lot of really interesting kind of asset tracker use cases for
Yes.
Sidewalk, just because, again, the kind of ubiquitous broad connectivity that it provides. Using Sidewalk as a transport, and being able to, again, gather location data, whether you've got a GPS receiver on the device, or GNSS,
Hmm.
or even Wi-Fi passive scanning. I think there's a lot of really interesting use cases looking at Sidewalk as a transport, and maybe our AWS IoT device location services, where we have a number of solvers that, if you can provide kind of the location sensor data, it can resolve a location based on kind of a variety of different data point types. So.
No, that's really cool. Um, I'm like, immediately I'm thinking about two things. One is privacy and kind of security around this, and the second one is kind of like this SDKs, but we can come to that later, I guess. So
Yeah,
maybe
yeah.
we can start with this security and privacy. Like, how does Amazon make sure that this is on point as
Ab-
well?
Absolutely. The Amazon Sidewalk team went to great lengths to ensure security and privacy of the data, uh,
Hmm.
or endpoint to application server in the cloud, at IoT Core. And there are multiple levels of encryption, and metadata even is completely minimized. There is an entire security white paper that I think we can provide as a link
Hmm.
here
Hmm.
after the show for any of the in the audience to review. But I mean, even the gateways don't even know which devices are connected to them. It is, again, we're really taking security and privacy first on this one. And so it's, again, it's something that's definitely been front of mind as the entire, again, network was developed and deployed. And so I'd encourage again, any of the listeners to take a look at that white paper. If you have any questions about, how protected is that data from, source to sync in the cloud.
Nice. I put this in the comments so that people can review it. I mean, I the reason why I'm also asking, like, I'm currently living in Berlin, Germany, and here, there is this GDPR, and you have kind of this data processor and data controller and all that semantics, which you have to kind of worry about. So I haven't read the white paper, but now that I have the link, I'll probably go over and see, how that is kind of resolved. But speaking about this, what is the network coverage at the moment, and like how will it scale? Again, the reason why I'm wondering, I am located in Europe, and
Sure, sure.
I don't have access to this, unfortunately. So maybe you can share some light on that.
Yeah, absolutely. So, today we get about, again, 90% population coverage. And maybe I can just kind of show you quickly. We do have a coverage map up, and let me show that.
Yeah, I think you need to.
Let me know when you can see my screen.
Yeah, there it is.
So you'll see. So this is a coverage map. You can find it at coverage.sidewalk.amazon, and to kind of explore coverage in your area. This technology, this network is enabled only in the United States currently, but there are certainly plans to roll out to many other regions in the world. And this, you'll see, I'm based outside of Austin, Texas, and because the gateways and bridges are built into these consumer devices like Echo and Ring devices, you'll see this is where the coverage, you'll see the coverage is the best around these population centers. And but you'll see is you get into this, it really does provide a pretty massive footprint, if you will, of the overall network. So
yes. This is like whoever owns an Echo, or what type of devices, by the way, can you list them? Do you know?
Yeah, so there's actually a complete list in the sidewalk documentation pages. There's like 30 or 40 devices that are used as part of this network infrastructure. And there's kind of a decoder in there as to what radio types are supported. And and I think that's important to understand here is for all these devices deployed, this is really, again, this is where the footprint of this network is really born from, was the deployment of these devices. And so, and of course, any Amazon customer is able to opt out of this feature on these devices as well. But like I said, it's something that operates completely in the background. Think of Apple AirTags, for example, leveraging the footprint of iPhones as the kind of network for finding AirTags. This operates in kind of a similar way there. So, but we do certainly give the consumer all the control they need to opt out if they don't want to participate in this community network.
Nice. Yeah. This looks really, spread out. So this is pretty cool. But
this is where, the use case, from a use case perspective, I think this is where, we have to be realistic about where's the coverage. If you want to take advantage of this kind of massive network, there are areas. We do have a Sidewalk Pro Gateway as well that has some pretty incredible performance that can be used to deploy in areas where the coverage isn't quite there, maybe in some agricultural areas. But just to simply, if you don't want to worry about the gateway at all, and you're developing a consumer device, maybe installed around the home or offices, there is a very good very good chance that the coverage will be there. So
I mean, like city centers and so forth. It's kind of probably
Yeah,
all covered.
if we look at the East Coast of the
East
United
Coast.
States.
Yeah, I can see this. Like, yeah. No, that's pretty cool. Okay, but yeah, now that, as I mentioned, I had these two questions. The second one was in regards to the SDKs, like, when
Mhm.
what kind of supports, like, I as a developer will now start in developing a Amazon Sidewalk type of device. So what options do I have?
Yeah, certainly. So we have a number of different hardware partners. I work with a number of our silicon partners as well in the ecosystem here. But at launch, between Silicon Labs, Nordic, Texas Instruments, and then Quectel from a module standpoint, uh,
Hmm.
these provide, our hardware partners here provide the device side support through their SDKs. And here I'll share a slide that provides kind of a summary of how of the parts and availability here.
Hmm.
Just share my
Cool.
screen again. And so this slide kind of provides this summary today. So the very
Nice.
popular NRF 52840 device. And so again, from the radio perspective, a lot of these devices have BLE built in, with the inclusion of the Simtech SX 1262
Hmm. Hmm.
radio. This is where FSK and LoRa come in as well.
Hmm.
And so again, and then in the case of Quectel, with the Quectel, the KG100 module, all the
Oh
radios
yeah, right.
are
Very
included.
cool.
And I believe that the Quectel module uses a Silicon Labs and EFR 32 part along with the radios, but again, all pre-certified from an agency perspective. And so this kind of provides the map of technologies, from a hardware perspective. And each of our silicon vendors has their own sidewalk landing pages and getting started guides. And so the SDKs are natively are integrated into their tool chains. And so like NRF Connect, or Simplicity Studio from Silicon Labs. And so each of these have kind of a whole developer experience built into it. And we can share some of those links to our silicon partner sidewalk pages for anybody, again, interested in learning a bit more.
Hmm. Yeah, I pasted this in the chat. So this. Yeah. So basically, what you're saying is, like, those hardware vendors, they have their own SDKs, so that whenever you start building something using them, they can kind of get you up to speed on this. This is pretty cool.
Yeah,
Excellent.
absolutely. And gosh, when you look at this too from a cost perspective, comparing it to cell modems,
Yes.
or even potentially Wi-Fi. I mean, again, this is where you can really build a very low cost device with this technology that not just in silicon cost, but in power cost as well. I mean, that's one of those things that an old architect had always told me, power is cost. And
Yes.
the more the more power efficient your design is, the smaller the battery, which again all kind of equates to cost.
Yeah, definitely. Yeah. I mean, energy consumption is always critical. Yeah. Excellent. I don't know. Did we answer in terms of, like, scaling the network? I don't know what the.
I think so. I mean, I can't give too many more details other than the plans are in place. I'll say, so that our friends and outside of the United States will be able to take advantage of this technology.
I'm looking forward to this. Excellent. Cool. Then you know what? You mentioned the demo. Maybe it would be a good time to kind of jump into this.
Yeah, yeah. Let's do this. I'd like to do a little show and tell here
Yes.
now,
Yes. Please
and
do.
I've got a couple of different things to show. one I wanted to show, which is just a really neat, I'll say neat device, which is the coverage test kit, and I'll show this here on camera. This is a
Let
little
me.
ring device, battery powered, that has a GPS receiver in it, leverages the Sidewalk network, and folks can request a coverage test kit to again test out the Sidewalk network themselves. And what this provides is, through the Sidewalk webpage here, you really get your own little personal tracker with this, so that this is showing data. This web page is showing data from this device, tied to my account. And I'm outside of the Austin area, and I'll just show you a couple of the things that So you'll see on this map, you'll see as it's got line of sight to the sky. It's able to resolve GPS position. This shows you the latitude and longitude of the device, as well as kind of a relative signal quality here. And further down, there's a lot more data provided, with regarding number of packets, if they have GPS. If I was indoors, for example, we'll still be picking up the packets, but we might not be able to resolve the location, because this is again, this just has a GPS receiver in it that requires a lock on the satellite constellations. But again, it's a really neat tool to kind of test out the network in general. And I can go back. This will hold data for about for 90 days, and I can show you. I can go back back in time, and maybe just here over the last 3 months, just kind of give you a sampling of where Ben Cook has been for the last 3 months.
What kind of radio does this device have on it?
It uses a LoRa radio in it. A CSS radio to ensure the best coverage, best connectivity possible. And I think that's fairly common for these kind of asset tracker use cases.
Yes.
Is you want to ensure that they can reach out as they traverse the countryside.
Back in the past days, I was working on building a dog tracker. So this would have been perfect, but that was kind of like 7-8 years ago. So.
Oh yeah. This technology is perfect for that. Again, for a pet tracker kind of technology, for example. One of the things I wanted to show you was really interesting. I went on a camping trip in Central Texas, end of March, and I brought the tracker with me, or the coverage test kit with me, and just to get curiosity, because this is very sparse ranch land throughout, and I was pleasantly surprised that throughout my journey to an area outside of Brownwood, Texas, it was picking up my location all along. I mean, there was actually coverage out in these areas that I was really questioning whether I was going to get coverage or not. And so again, I think this kind of shows the capability of the technology and the network in general.
Oh, this is really cool.
So, in general, I will share that I do work from home, and I have sent this out. A good friend of mine has a rainwater harvesting business in the Austin area, and he's out in the field all the time, and so he was kind enough to include take the coverage test kit with him.
I see.
And as you see, going all around Austin and the hill country, we see a lot of location data, basically.
Yeah. I was about to mention you visited quite a lot of places in that month, but okay, that makes sense.
So again, this is the coverage test kit. Really lets folks test out the coverage for themselves. If there's any questions about, hey, what kind of coverage would I get in this area? Again, it's a pretty useful, really useful tool for trying it out. Now,
Nice.
And I think we'll provide links, if the audience wants to request one themselves, and some more information
Yeah.
as
Yeah,
well.
I put this in the comments. Cool.
Now,
I would actually be also interested to see like the application and how does that work under the hood,
yeah,
with like AWS IoT Core and all that stuff. Uh,
absolutely. Let's
Being
take
a geek of myself.
a few minutes to talk a bit about this. We have a sample up on GitHub.
Nice.
The Amazon IoT Core for Amazon Sidewalk sample app here. That what this sample app is it provides a kind of a reference architecture reference integration of kind of more of a full stack example from device endpoint up to all the way up to this page in the cloud. And what I'm showing here are I've got a number of devices from a variety of our silicon partners here around me in my home. And this sensor monitoring application, the sample app, provides you with it's kind of a blinky, if you will.
Mhm.
It helps engineers get a light blinking, shows
Yes.
how they can receive messages from devices and also do downlink, send command and control messages down to the devices as well. And so these devices, again, there is source for all three of the our silicon partners there at launch. Texas Instruments, Nordic, and Silicon Labs for all the radio types. But this application will show you a number of things. So the devices are sending temperature over time.
Mhm.
So you can look at temperature. If I have some freeze spray, I can hit one of these, and you'll see one of these devices see the temperature drop pretty
Nice.
significantly. It gives you some kind of basic command and control. It's maybe a little harder to see. I've got an LED on this board, and I can turn the LEDs on and off. And
Mhm.
then also some button interaction as well. You can push buttons on the board and see how, again, this kind of provides an end-to-end example of how one could um, build a device, build an endpoint that leverages this network, and provides a really good example of how the payload can be constructed, the
Nice.
integration into IoT Core, and then up through Lambda to a
Yeah.
place to persist data. And
Do you
maybe I'll
happen to have? Yeah, sorry. Do you happen to have like an architectural diagram of this? This would
yes,
be really
let me show you this.
nice. Nice. Oh yeah, this is.
So this is the full diagram, and the sample application itself includes pre-built binaries. Includes pre-built binaries for all of those platforms. And so really the exercise in the deployment of this is run a couple of scripts that deploy CloudFormation templates with
Mhm.
the infrastructure, and then the developer needs to provision the device. The provisioning of the device really ties it at that kind of lowest level of encryption to the IoT Core account. And so again, the exercise is program the application image to the endpoint, and then program do provision it so that the device, when it sends a message, is registered with the network, onboarded, and
Yeah.
then sends a message. The integration shows up in IoT Core through our IoT wireless integration. Kind of the same area of IoT Core that the LoRaWAN comes in.
Mhm.
And I want to just kind of talk through this diagram here briefly.
Mhm.
So there's a concept of a destination, and the destination, the device profile is really tied to this destination. The destination can be either a rule, trigger an IoT rule, or publish a message to the MQTT broker. And so this provides the path, for configuration, if you will, where these uplink messages land within IoT Core. And so a very common pattern for, I'd say, message processing from IoT Core is to trigger a rule. That rule will trigger a Lambda function that will then parse that payload and manipulate the data, and then store it somewhere. In this case, it was implemented with a DynamoDB database.
Mhm.
and such that then that the web application, is looking for, which devices have been uplinked, and then we'll decipher that and provide that nice GUI that we just saw.
Yeah.
And this also has, so this is kind of the uplink. There's another rule in here. So maybe most may know, but IoT Core emits events from devices as well, and that's where this sort of sidewalk notification rule comes in particular here in the middle of the screen. So this is a channel that shows as devices have been registered, but it also is used for that kind of feedback loop when command and control messages are sent down to the device. This is how that, you can get notified that, yes, the device did actually receive it all the way down to the endpoint through the network.
Oh, I see. Okay.
And so between these two kind of provides the uplink side. The downlink side, because again, this is not an IP, this is not an IP device. This isn't using MQTT. The way that downlink messages are sent are through the IoT Core wireless APIs. And so the message to the network, which down passes it down to the device and whichever gateway is closest to the device.
Yes.
And so, and maybe I've got here one more slide that maybe provides a little better detail here. I really wanted to just kind of show the audience that this is how you interact with the devices through the network with IoT Core. From an uplink perspective, the destination really defines whether those messages are going to come in and hit an IoT rule or publish to an MQTT topic. And then downlink, of course, is using the IoT Core wireless APIs, rolled up in a Lambda function and messages downstream.
This is really interesting. I mean, when you're kind of working with general IoT devices, your assumption is that they are IP based. They're connected via internet, and then they all have pub sub mechanisms using MQTT and all that. But in this scenario, it's a bit different. I mean, for the uplink, you kind of use those MQTT topics, but then for the downlink, you have to kind of use the IoT Core wireless APIs because as we said, there is no like a TCP connection between the device, and then there is some magic underneath that matches which gateway is the nearest and all that stuff, right? So
yeah, and that's I think those are some interesting points. Is that I think most that have worked with wireless technologies probably understand that BLE could provide is connection-based technology, whereas FSK or CSS, for example, are not connection-based. And I'll say for one, rule of thumb is IoT devices are never always connected. It's there's always the fringe of the deployment, or that IoT fleet is always I don't think I've ever seen one with 100% connectivity. And each our partners have some really interesting, silicon partners have some really interesting further details around each kind of connection type, each radio type as well, regarding the connectivity and when can the cloud interact with these devices. And so as I mentioned before, it's very much triggered by the device and uplink, and when the cloud can actually then send downstream messages to it. And so you're always kind of keying in on, when was the last message that was received, knowing that, the only time I can then really interact with that message is when it uplinks.
Yes, that's what I was about to mention as well. This kind of notification is really important because that kind of indicates what you're saying is that, okay, the device probably has a connectivity now. So if I wanted to say something to that device, this is my opportunity, right?
Exactly.
So, exactly. No, this is really, really interesting stuff. Okay. And about the partner network, I think you mentioned something in terms of the this kind of ODM, like device partners.
Yes, yeah, absolutely. So that's another. I think another good point is that we have a number of ODM partners as well that make white label, make finished goods that leverage Sidewalk, and
Hmm.
there's one of them I'll maybe show here briefly, is our partner Broen, that produces a kind of a variety of smart home sensors and security devices that can take advantage of Sidewalk. And so beyond Broen, Deviceroy, Meshify, there's kind of a sampling of ODMs that we could provide. I
Yeah.
think I shared the links. Maybe Nanad, you could share
Yeah.
them with the audience as well. So
Yes.
so again, if you're building an IoT solution and you kind of don't want to worry about the device side, these ODM partners provide, again, have designs that are built and fully qualified, that they can help connect them to your AWS account, your infrastructure, to build out a broader IoT
Nice.
solution.
Nice. So basically, they are using this what you showed in the background is like this kind of methodologies and the development kits and this kind of framework, and they already build those ready to be used devices so that the end consumers can just buy it and then use it. Oh yeah.
Yeah, absolutely. And and if there are any device makers, in the field, I think one of the really interesting opportunities for Sidewalk are brownfield migrations. I mean, you
Hmm.
taking a current system that is, a BLE based sensor that requires a mobile app, and if it uses, say, the NRF 52840, for example,
Hmm.
that could be converted. Existing devices could be migrated to remove the need for that mobile application and leverage Sidewalk. And so again, as much as CSS and LoRa gets a lot of the limelight, so to say,
Yeah.
because of the range that it offers. If you look at the deployment of BLE devices in general, it's pretty massive. And so this is an opportunity to improve existing devices in the field as well, to remove that kind of
I see.
undifferentiated heavy lift of a mobile application in order to surface that data to the cloud.
Yeah, yeah, especially what you mentioned there with this kind of elderly care, where they in some scenarios they are not proficient users of like mobile applications and so forth, and then if they can have that kind of connectivity and then they don't need to care about that's a benefit. Sorry, it seems that my camera died for some reason. I don't know what happened there.
Yeah,
But
no,
yeah.
um,
Okay, this is really, really interesting stuff. I really enjoyed this talk. I don't know anything you wanted to add as kind of the last thing, since we are almost at the end.
I no, I've really enjoyed the conversation, and again, I'm really excited at the prospect that Sidewalk has to really improve kind of IoT connectivity in general, but then also
Hmm.
on the sustainability side of things, really help reduce the power envelope of a number of devices. And I think that in general, it's a really exciting technology, and really looking forward to seeing how it grows and how our customers are using it, because again, it really it provides some potentially very interesting use cases. I mean, even in again, the multi-radio type of approach, where if you were maybe using that Quectel module, you could build a device that gets the best of both worlds of range of CSS but higher
Yeah.
throughput with BLE. And there might be some different kind of customer usage scenarios there that enable the device to be have long range, but then also have better throughput for various events. So again, in general, I think that's an area that I'm looking forward to exploring some more, is how these the combination of the three radios can
Hmm.
open up a number of new use cases.
Yeah. I mean, the thing that I also love about this project is that it is kind of more or less, you can see that it's community driven, plus there is a component of the partner network as well. So it's like a multiple parties kind of coming together to create that the IoT infrastructure, so for kind of the many type of devices to coexist. I think this is what I love in general about this project. So it really unlocks quite a lot of different use cases, as you mentioned earlier. So it's really interesting.
Yeah, indeed. Okay, excellent.
Excellent. Okay, so anything to say to our audience in terms of what they can go forward and check out? I think we shared quite a lot of links. Hopefully, they can explore this and then build some new cool use cases for the future.
Yeah, yeah, absolutely. I'd encourage anyone in the audience to check out the links that we've shared, and maybe pick up a coverage test kit or one of our partner HDKs, and get to hacking. I mean, I think you'll be thoroughly impressed with, again, the coverage and what this technology can provide. Again, especially if you're looking at, again, other LPWAN technologies or building devices, maybe BLE based, for example, that you may still need a mobile app, want a mobile app from a customer experience perspective, but you then might not have to worry about them always interacting with the app in order to get the data to the cloud.
Excellent. Yeah. From my side, I'm just looking forward for this to be available in Europe.
Indeed, I've heard that from a number of our
But other than that, this looks amazing. I will definitely start kind of trying it out. Excellent. Okay, I think that was all. I guess what we wanted to cover in this discussion. So thanks once again, Ben. Thanks for joining me in this. And for you guys out there, hopefully you can tune in next week. We'll also have some new guests joining as well. So thanks everybody, and talk to you next week. Bye.